class. This is Professor Nick Sensky at UNC Charlotte, and this is week 2 of Computational Methods, the pre-lab tutorial. So every week I'm going to give you one of these tutorials online and expect you to follow along with it. So watch the video and pause it and then try to do what I'm showing you. Don't try to do it at the same time, okay? So just like we try to do in lab on Thursday, it's important to kind of take everything in so you don't get lost and experiment with it yourself, okay? So everything that I do here, I expect you to do on the computer and try it multiple times and, you know, break things and ask questions, but really just explore it, okay? At a minimum, you need to run through all this stuff at least one time so that you understand where the commands are and how they work, and this is just going to prepare you for lab, okay? So get everything started, open up Rhino and Grasshopper, get them laid out the way we had in lab with the Windows keys, and I'm going to go ahead. And these are blank files, starting without anything inside the file, okay? So what I'm going to do is go ahead and start by creating the sketch, the script that we had in lab on Thursday. And to do that, I'm going to go ahead and start with a box component. And everything in Grasshopper are called components, okay? That's kind of the language we use. There's different ways of getting components onto the stage here. The most straightforward way is to navigate the tabs. So you can actually click on these. There's curves and surfaces. We're going to go to surface, open up primitive, so click here, and then we're going to make a center box. Click on that, and then you click somewhere on the screen, and your component comes up. Okay. The other way you can do it, I'm actually going to remove this. So I click it and press delete, and that deletes it. Okay. The other way you can do it is to double click and type in what you're looking for. So I can say I want a box. And what I want, again, is a center box, not a box 2-point or a box collection. I want a center box. Okay. We'll look at those commands in later classes, but right now it's just a center box. Okay. And let's examine this component that we have. Every time you have a new component, one that you haven't used before, or you're not sure how to use it, you want to mouse over the letters. And these are the inputs, and this is the output. And the input, so it starts off with a B. It looks for base plane. You can see in the upper right-hand corner it says plane. Okay, so it needs to know where to make the box, and it asks for a plane. The box component actually defaults to the XY plane at 0, 0, 0. So that's why we actually see a box right now. The other defaults are it has the size of the box in the X direction, and in this case the size is 1.0. If you look at the input, it says it wants a number. Look in the upper right hand corner, it says number. Okay, so if you give the box a number, that's going to change the output, and the output is a box, you know, B. Okay, so XYZ are numbers for the size in the XYZ location, and then this B is actually a plane. Okay, it's a base plane. Okay, should be P, I think, because it gets confused with B for box, but I didn't design it, so so that's a box component. It's a 1 by 1 by 1 box that's at 0, 0, 0. Okay, notice it's actually centered on the plane. That's why it's a center box. So the whole length of it, the whole height of it, the whole width of it are 1. So this is actually 0.5 in the Z and negative 0.5 in the Z. Okay, it's a little weird. If you look at the front view, so look at where my mouse is, and you can get a sense of, and actually looking at so 1.0. Actually, it looks like the dimensions are 1. It must be the radius of it. Actually, it's 1 and 1. You can see the coordinates in the bottom of the screen. You can verify this experimentally. Anyway, interesting. So we're not really interested in dimensions right now so much as proportions. So that's kind of neither here nor there. But go to perspective view. Okay, so we got my box. And to set up the thing the way that we had looked at it in class, we're going to go ahead and add some number sliders. So double click number slider. And I'm going to just jump right into this, and then I'm going to explain it. So if you take a number slider, it has this little knob on the end of it. If you click the mouse and hold it, and you can plug it into one of these numbers here, x. That's going to let me control the x dimension. So again, x changes 0.772, which changes the box output. Okay. I'm going to copy paste these, so copy paste. Copy paste. So that's Control C, Control V. You can also go in and say, copy, and then paste. Okay, but you don't need to do that. You should be using the keyboard keys anyway for most of your commands. It's faster. Plug these in for x, for y and z, and now I can control the dimensions parametrically. So there's a one-to-one relationship to each of these variables and their expression in the box object. And they're independent of each other. I change the x, nothing happens to the y. Okay? So I can do different things with them, but first I'm going to set up the sliders a little bit differently. These aren't very exciting right now. So if I right-click on the slider and I go to Edit, I can go through and I can change the min and max. So I can say the maximum is going to be, let's say, 10. And I can change the name of it, so I can actually call this length now. And names are really important for variables and for parameters, okay? You need to give that variable meaning. Otherwise, it's just slider, and it's just a number, okay? Giving it meaning is helpful because as you work on these, you're going to start to forget what you were doing. You might come back to it later, and you don't know what that slider does. If you give it to somebody else, they're not going to know what it does. So names are very important. You need to choose them carefully, and you need to make sure that you always use them, okay? When I look at your sketches, when you look at your scripts, I don't want to see a bunch of things that just say slider. You gotta name them, okay? That's part of the craft of programming. Other things you can do, you can change the things to integer numbers, which are whole numbers. 1, 2, 3, 4, not 1.2 or 4.8, just whole numbers. Even numbers and odd numbers. We're not going to mess with these today, but that's really interesting, though. You can do some interesting things with that. Let's go back to floating point numbers. These have a decimal. You can change the precision of the decimal, so you could say, like, I'm only interested in tenths, or 10,000ths, 100,000ths, I guess, okay? I don't know, I'm just going to keep the default at 3. It's not that important. Press OK. So now I've got a different slider, and now this one can go all the way out to 10. These guys are only capable of going from 0 to 1, okay? So that actually is an interesting thing too. If you know that you're going to make a copy of something, like I'm interested in making all these from 0 to 10, don't change this one and then go in and like change this one to 10. Just what you want to do is copy the one that's already got most of the attributes that you want, and then just go ahead and make your modifications to it. Okay, change your name. So now this is width, and this one's height. It's much faster this way. So now we've got a 10 by 10 by 10, possible range of cubes. Okay. You can organize these if you if you select them, and then you click on these align arrows. So I can align them all to the left. I can distribute them all vertically evenly, so it's kind of nice to keep things organized. Okay, so that's the one that I gave you in class on Thursday, just the basic kind of parametric object. Okay, let's mess around with it a little bit. Right-click on Y and go to disconnect and say disconnect all. And so that actually takes off this component, and you'll see that Y actually defaults back to 1. You can always mouse over to find out what the value is. And let's go ahead and disconnect. No. Let's take, one thing too, if you change the length of these, it doesn't actually change the value, it just changes your ability, it just makes them, it changes what you see, the length that you can scrub. That might help you make more precise adjustments, but it doesn't actually change the values. Okay. Let's go back and let's go for Z, but let's make Y and Z the same. X and Y the same. So now, get this out of the way here. You're essentially scaling in this direction, and Z is here. So now Y is dependent upon X. They're at least sharing the same value. They have a relationship that's 1 to 1. And now Z is independent. If you plug this in for all three, you're going to be able to scale them all in each direction. That might change the name of this, right? Now maybe it might be just size or something, okay? So I'm going to do Control Z, and undo all that. There we go. So now we're back to what we were. Okay? Let's experiment a little bit. So relationships are a key thing. So we have variables, parameters, right, that drive the object. But sometimes we want to do things that relate them in different ways. We might want to make the width twice the length, or the height some other proportion of it. So we can do that using some of the math components. And in the math components, we have like addition, multiplication, negative, which makes a value negative, subtraction. Okay, so let's add a multiplication component. Multiplication component takes a number, some kind of data, and some other data, and outputs the multiple. Pretty straightforward. So if we did the length times the width, and you get a new value for r. Now you notice that again we don't know what that value is, like we can't actually see it. So one trick you can do is to add a panel component. And a panel component is a little box, a little yellow box, and it'll show you the result of something. It doesn't affect it, it just shows it to you. And then you can plug this in for Z. And so now we know that now the height's like 12, and the height's actually 43, because it's 7 times 5 roughly. And you can actually see how that's changing. So the length comes in, and the width comes in. So you can see how those are actually affecting each other in the way that the box is shown. Okay. So that's kind of like some of the things I was doing in class. You can do some other things too, where let's say Z, let's do addition, and let's take A and B, and now that's 8. And so it's pretty much, as the width change, height changes. Okay. So these are the kinds of things that I set up. So you can make various relationships to each other using these math components, and that's just a really like simplified way of showing the kinds of things I set up in class on Thursday. You should experiment with them. I mean, try to make things that have inverse relationships. Try all the different components out, and just again, it's about taking the input and applying some kind of relationship, and then processing the output. Okay. So something else you can do that I encourage you to do is to experiment with some of the other shapes that we have. So if you go in, the ones I want you to look at are under surfaces, check out cone and cylinder and sphere, because those are pretty generic. So you can see like you have a base plane, a radius, and a height. So if you plug in a variable for it, it's kind of easy to see how the variables affect it. Just get a sense of what's possible in the program, like what kinds of primitives you have to work with. Okay. Other ones you want to play with that I recommend are circle, ellipse, arc, polygon. I wouldn't mess with rectangle right now. It's got some commands in it that are a little more complicated than what we're at right now. But these other ones are straightforward. Just quick take a look at polygon. So again, it's unfamiliar. These are shapes. These are just two-dimensional shapes, like lines. Okay. Polygon wants a base plane, which we don't need to mess with. A radius, it's a number. A number of segments, it actually wants an integer, so you need a whole number. You can't have like 5.5 sides, right? You have to have a whole number. and then this fillet radius. And if you don't know what fillet radius is, well, you know that it wants a number, so you could experiment with that. So let's go ahead and make some modifications to these. So we're going to do integer numbers, and we're going to call this sides. So this is the number of sides that we have. And we're going to take this one, and we're going to make this one fillet, because that's what it wants. And we're going to make this one radius. Okay, so radius, number of sides, and fillet. And let's just organize these a bit. Okay. Interesting. So when you have a really high fillet, it looks like it rounds off all the corners a lot, and you get a circle. And likewise, if you have a lot of sides, it starts to become more and more circular. And if you go lower than 3, you break the component. It turns orange. So when that happens, if you don't know what's happening, you can mouse over the little warning flag, and it'll tell you what that error means. And so in this case, it says the polygon must have at least 3 sides. Okay? So, you know, you can't have a polygon that's less than 3-sided, right? Nothing less than a triangle. So what you can do is when you design your number slider, you could go in and you actually would say, okay, the minimum is 3. Okay, then that constraint's in there. You can never break that. You've already set the rule. Okay. Interesting thing about fillet, you look at that, a very small change seems to produce a pretty large effect right now. So why don't we go ahead and limit our range to something like 4. We don't want to keep rounding this thing until it's gone. We want more control over it. And the radius seems to be pretty self-explanatory for us. So we change the number of sides and something. So pretty cool. You can experiment with that. But that's a polygon tool, and that can be pretty useful. Okay. Another piece I want to show you briefly. So we looked at number sliders as a means of manipulating a component, right? So we plug this in, and you can, go from 0 to 10. What if you know something's got a fixed amount, like it's not going to change? Okay, there's different ways of implementing that. That's what we might call a constant. And the one that I showed you guys, I did a number component. So I took a number, and if you right-click and say set number, I can call this, let's say 5. And I plug this in for z, and then it's always going to be 5, no matter what I do to it. It's always going to be 5. Let's go ahead. Now, I'm violating my own rules here. I'm not really naming these things. Shame on me. But you will, right? Whenever you play with stuff, always give things a name. In fact, I'm going to do it anyway. I need to practice what I preach here. Okay. So length and width are independent. Z is a constant. And that says num. That's lame, right? It's actually 5. So let's go ahead and rename it to 5. That way we just know what we've got. Okay. If you change this, right, nothing happens. That's just a label. You need to set the number in order to actually make the change. Okay? Be careful with that. Another thing you can do that might avoid that problem for you is to use a panel component as a data source. So we've used panels, and I've shown it to you, and it shows you what the value of something is. Okay, I'm going to disconnect this. You can also use a panel component to send data to something. And what I can do is right-click it, and I can say multi-line data. You have to do that, okay? And then if I double-click it, I can make this 4. And then if I plug this in for z, now it's sending data. And if I want to edit it, I can change it to 7. Okay, double click to edit. So that's kind of cool because it not only displays what's going on, but it also sends the data So it's very useful. I find it, I don't know, if you know that you're not going to change it, it's purely aesthetic for me, but like, I kind of like to just use the number component instead, because it's just, this is so clunky, and it stands out. But, if you think you're going to have a constant, but that you might occasionally change, I guess a panel's not a bad idea. You might see that in some other people's sketches, so that's why I bring it up. Feel free to use what you want, as long as you think about what you're doing, okay? It just might be your style. Another thing you can do that works, what I don't like, is you can right-click the component number, the component variable, and you can change it just by typing it in. So I can say 6. Now, that works, right? You have a constant. But the problem with it is that you don't see that you've made that change. And so you might just assume that it's a default of some sort. You don't know what that default is. Okay? Which is why you really want to do something like this. Because it's visible. Just in the same reason why we have to label things, you need to make your variables explicit. If you're an expert, maybe you can get away with just setting the numbers in there, but I find that I forget that I've done that. Okay? So that's how we can get constants into our system. And you can plug this in and you do this. So now the width and the height are the same, but the length is changing. This would be, you might need this sometime, I don't know. So you say that this box is 6 by 6 by 6. Very explicit. Okay? Okay. So that's a pretty good introduction to, how you can get, you can associate variables with the different parameters in your component. Okay? We don't have a design problem yet. Like, there's nothing that we're trying to solve or that we're trying to make. So we're not really, there's not much intelligence in these yet. I just wanted to give you a sense of where the tools are, how they operate, what the options are. Okay. You should be able now to understand and construct the first 2 examples, the box and box 2 example. The other ones are going to be a little bit more complicated, but I think you might intuit a sense of how I did the relationships with the house from this. Okay? So the next thing that I want to do is I'm going to go ahead and start with my box. And see, and the parameters changed, and I expected it to be 1 by 1 by 1, but I set the number. So go ahead and set this back. Actually, I don't want anything in it. Oh, actually, if it has nothing in it, it crashes. So I want to do 1. Fine. Okay. So I've got my box, and I want to show you something you can do with a box called a transform. Actually, you can do it with any geometry. Transforms are really important in modeling. It's essentially how you take a form and apply some mathematical, some kind of mathematical equation, and you make it a different form. So it's a transformation. And the easiest transformation, the one that's easiest to understand, is just moving something. Okay? So I can go in and I can say move. And I take the box, and move wants geometry, and move wants a vector. And if you remember from geometry in high school, a vector is kind of like a line. It has a direction, and it has a magnitude, and it kind of points towards something. Okay? And in our case, what we're interested in is if I want to move the box, in the X direction, or in the Y direction, or in the Z. You can see the little compass down here that helps you understand where that is. Those are vectors. Okay. If I want to move something here, I'm looking at an X vector. I want to move something up this way, I want a Y vector. Okay. So let's move this into Z vector. So I go in, double click, and let's say, I'm sorry, X vector. X for a unit X vector, and plug it in. And so now that's fine. I've got a translation vector. And then I plug the box into G, and you'll notice that I had a box, and I changed the state of it using the move component to a box that moved. Okay, so again, remember I tried to explain this in lab. It's kind of a hard concept to understand, but so the system had a state where it had a box, and then I modified that, and now I have this box that's been moved. So this box is available if I want to do other things to it, but it also kind of moved on, right? So I can go in and I can right click and say preview off, and I can turn off so I don't see that box anymore, that initial state. So I've got this, it's kind of grayed out, and the new box is over here. Okay, so it's moved. You can see it's not centered on 0, 0, 0 anymore. Then I can take a number slider, because the vector has a magnitude, it has a multiplication factor. And if I plug in a slider to it, I'll show you really quickly. So now I can move it. Let's go ahead and modify this. And I'll say 10 and negative 10. And now I can make the box kind of moonwalk. Okay. And again, if I turn preview on, the other box is still there. But now I'm changing it. And okay, why is it interesting that there's still a box there and there's this other box over here? Well, we can do something like this. I can make another move component, and let's plug in the geometry from this state and plug it in to this one. Actually, let's plug in the other one. So you should probably notice this, but if you plug something into something that's already got a plug, it disconnects the old one and plugs in the new one. Take a Z. Let's drag the slider here and plug it in. And now I'm moving the first box. So there's a state of the box that's moved up into Z, and there's a state of the box that's moved into X. Okay. Let's go ahead and take this structure, copy paste it, and let's take this geometry that we moved in the X and plug it in to the same structure, and now we've got a box that we move in the X and then we move into Z, and one that we don't move and we only move into Z. And let's clear things up a bit. So we'll hide the initial state of the box off, and we'll hide the box that we moved. And so now we have two boxes that are a certain distance from each other that we can move kind of up and down. Okay? And I think I said this in class, but I'll tell you now, you can double click a slider and just type in what you want. So let's set these both to 0 for the time being. Okay. So we can move these things up and down. Let's do some kind of funky stuff with them. Let's make it so that as one box moves up, the other box moves down. So we have one slider, and if I move this one, it changes the number and it goes up. What I'm going to do is I'm going to make a subtraction component, and I'm going to pipe this in, so it's 10, and I'm going to take a number component, and I'm going to make this 10, and set the number to 10. And now I messed up. So it's A minus B, so let's say 10 minus whatever this number is. And let's plug a panel in, right? Because we want to see what's going on here. It's really hard to tell. So now it's 0, and you can see that the number is like 11. So let's plug this in, this new number. This is getting a little confusing here. So instead of having this independent one here, we're going to make this dependent on this new number that we made. So whatever this number is, so 10 minus whatever this number is, and so here it's 0, so 10 minus 10 is 0, and 10 minus 0 is 10, and then we start going negative, and so now it's 10 minus negative 10. So there's an inverse relationship between those two inputs. you can do this with like multiplication and do some different interesting kind of things to it. You can do this with various things. I just want to show you there's a way like we can do this in such a way that these are, let's say, like a multiple of one another. So this one, and let's just make a slider for this one. So let's go ahead and say whole numbers, and we'll do mult 5. And plug this in. So now it's 0. Okay. So let's just go ahead and start this at 0. I won't be too confusing. So these are both at 0. And right now this one, I'm moving it up. And now if I add a multiple, so this one's the same, twice as high, 3 times as high, 4 times as high. Okay? So you've got a multiple. Should probably organize this a little bit better. In any case, so we have a box, and I think it's still parametric, so I can still change this relationship even as I change this relationship. So again, not to get too confusing, but the principle here is that you can make different relationships to each other using math, and you can decide which ones you want to control or which ones you want to make constants. And it's always good to visualize what's going on inside your program using things like panel components. You don't want to not know what's going on with it. Still kind of experimental, right? We're not really doing design problems yet, but hopefully this is kind of illustrating some of the principles of these transforms. So move is a transform, and move actually, if you think about it, gives you a copy of something that's just in a different location. And we'll see in a while why that's really useful. Okay. So let's take what we've got right now and delete most of it here. So just delete this, and let's unhide. Let's preview both of these boxes again. So we have two kind of twin boxes, center boxes, and we made a copy of one. What I want to do next is do another transform, rotate. Let's look at rotate. Rotate takes geometry. It takes an angle in radians, which is going to be some trouble because I don't know about you, but I don't work in radians, I work in degrees. So we'll look at that. And then lastly, it takes a rotation plane. So let's go ahead and just take the first box and plug it in for the geometry. We're going to rotate the box. Okay. Then let's set up a slider for degrees. What would the constraints be? They'd be 0 to 360. Right? And let's just call this rotation angle or something like that. Okay. And yep, looks good. You'll notice, I'll just demonstrate this. If you plug this in for your angle, okay, first of all, you still have this old box state, and you have the rotated state on top of each other, so it's kind of hard to make out. So let's just go ahead and turn preview off. So now we have a box that rotates and a box that doesn't. But look at how crazy that rotation is. You can't, it's not, that's because it's feeding this in and it wants radians, but we gave it, rotation in, so we gave the rotation as 360 like degrees instead of radians. So we want to do a radians component, which will take degrees and convert it to radians. Okay. Plug that in. Now we can work in degrees, and the computer gets its radians, and everyone's happy. Pretty good. Let's give this a little bump in the Y, just so that we can see the difference, so we know. So that's a full rotation. Cubes, it looks like they're rotating faster than they really are. Okay, so it's a full 360. Okay, so there's that one, and there's a difference between that one. And then we have this other geometry, and we want to rotate it. So we copy this assembly, take the geometry, pipe it into here. Let's go ahead and turn off preview. Everything should be fine, right? Let's go ahead and rotate that one. Whoa. So now it's like orbiting. This one rotates around, its kind of center point. This other block, turn preview back on, seems to be orbiting around the center. The reason for that is because its rotation plane, it's using the default rotation plane, which is XY, it's 0, 0, 0. So its point of rotation, it's pivoting around here. That's fine for this first box because 0, 0, 0 is where the box like starts off, right? Sorry about that. But we moved it, right? Which is actually kind of interesting because we can kind of move this, and the rotation is going to change. So this is actually an interesting demonstration of like state here. Okay, but we don't really want that. I want them both to rotate around their own kind of center. So to do that, we need to establish the plane for this piece. And one quick way to do that is to use the volume component. And what that is it takes geometry, and it gives you it gives you the volume as a number, and it also gives you the centroid, which is the center location of that. Okay, so if I plug in G, you can see I get a little point that's in the center of this on my volume component. If I plug that in to see the centroid for my P, my plane, now when I rotate, it's going to rotate the way I want to. So I can do these things rotating each other. Okay. Real quick, let's do another relationship. Let's have one of these rotate at half the speed of the other one. So let's do a division component. And let's drop a number component. Let's say 2 and 2. So A divided by B, A divided so 1 to, whatever this number is divided by 2. In for my degrees. Let's kind of separate this out a little bit. So my angles, so you can see that when one rotates 360 degrees, and actually I kind of violated my own, let's do a panel here. This one's only rotated 180 degrees. I can make it even smaller. I could divide this by 4 and really bring it out of sync. So now it only rotates 90 degrees when the other one rotates 360 degrees. Just some games for now. Just going to play with this, but just experiment, see what different kinds of things that you can relate it to. You can give them opposite angles. So I could do negative. So I throw my number in, and I'll plug that in instead. So let's do negative. So now it's negative 360, which is actually 360, but whatever. And you can see that they spin in opposite directions. Interesting. Okay, so rotate. The big thing to know about rotate is this idea of this rotation plane. Sometimes you want things to orbit, and sometimes you want things to spin. Okay, so you got to pay attention to that. Also pay attention to this idea that you want radians, not degrees. So you need to convert to radians. Okay. Let's look at one last transform, and then we'll be done with this. So let's go back to my pieces here. Turn preview on. The next thing I want to talk about is the scale component. Scale takes geometry, takes a center of scaling, which is a point in this case, so that's interesting, and a scaling factor. And a scaling factor, right, would be a multiple. So 0.5 is half, 2 would be double. Okay? So let's make a scale slider. And let's just do like 1 to 3 or something. 0 to 3. let's go ahead and start the way we did last time. Just plug in the geometry, and you can see scale. Let's go ahead and turn this off. So we can scale small. Oh, what happens when we get to 0? It breaks. Why? Because you can't scale by 0. So what we could do is do something like change the slider minimum to 0.001, and then there's no way that it'll break. We have a constraint that doesn't allow for illegal numbers. Okay, so you can scale. The other one's not scaling. Let's go ahead and scale the other one. So take the geometry, pipe it in for G. Uh-oh, some weird's happening here. So look at that. We would expect it to be scaling. You know what's happening is that it's scaling this by the XY plane at 0, 0, 0. But the point of scaling, the center of scaling, should be inside of the object. We saw a parameter, right? We saw one of these Grasshopper like components that allowed us to find the center of an object, right? The centroid. Remember what that was? It's the volume component. Just like the one we used when we did rotation. So take a volume component, pipe it in to the rectangle that's been moved, and pipe that back into scale, and let's go ahead and hide the old one. Now we're cooking, okay? So that's pretty good. And once again, you know, the whole thing's parametric, so we can move it. Okay, so got the scale. Then we can play games with it again. We could go ahead and we could make one like let's see here. Let's do another one of these subtraction ones. So let's say you can also do a thing here. I should say you can extract the parameter, which will actually pop out a little type in, and that's kind of nice. Instead of having to make a number component and dropping it in. Let's say 4 minus whatever this number is, and then remember, we probably want to do a panel. You don't have to, but it helps. So as this number gets bigger, the other number gets smaller, and vice versa. And we are going to use that as the scaling factor for this guy. And there we go. Okay. With boxes, it's not that exciting to scale them because we can kind of play with the dimensions here. But when you get into other forms, it becomes more important, more complicated forms. Remember, any geometry can be piped into scale. So once we've made a complicated form or a collection of forms, scale becomes more important. But again, you have to look at the centroid. The center of scaling is really important. Because it's the difference between scaling something, you know, from the center, which is the way you probably expect it to, and some disturbing forms that you probably didn't want. Okay? So, you know, this has been a really basic introduction to parameters and the different kinds of relationships that we can create with variables. Experiment with the different shapes and surfaces that I introduced you to. Get to know their settings. Try to combine them in different ways. Like, just explore a bit. Practice what I've shown you. So you can start to get the effects that you want. Again, I haven't given you any kind of design problems yet, but it's important to kind of establish what's possible and what works and what breaks it. Okay? If things don't behave the way you expect, investigate that. Okay? And ask questions about it. Like, talk to your peers, talk to me about it. A lot of this is with your willingness to explore it. And the other thing I want you to do is experiment with these transforms. So move, scale, rotate, combine them. Try to see if you can move an object on top of another object parametrically, right? That's sort of how we did the house example. Okay? But play with this and bring questions to class, and I'll see you guys in lab on Thursday.